Welcome back, everyone, to TalkTensors. You know, we love to dig into the latest AI research, and today we're looking at a paper that caught my eye because it tackles something that I think we all can relate to: visuals.
Visuals,
Like
yeah.
using visuals to help explain tough concepts.
Absolutely.
Even in something as abstract as math.
You're right. It's like a picture can really be worth 1,000 equations sometimes.
Exactly. So this paper is titled From Text to Visuals: Using LLMs to Generate Math Diagrams with Vector Graphics. And it dives into this idea of, well, you know, how can we use AI to actually create those helpful visuals for us specifically in math?
Yeah, that's the big question, right? Like, can we automate the process of making these math diagrams? And the authors here are exploring using what we call large language models, or LLMs for short, to do just that.
Okay, LLM. So we're talking like the big, powerful language AI models, like the ones that can write stories or translate languages.
Yeah, those are the ones. And the interesting thing is they're focusing on generating these diagrams in a format called SVG.
SVG now, for those of us who aren't, you know, graphic design experts, can you break down what SVG is and why it matters in this context?
Sure. So SVG stands for scalable vector graphics. And it's basically a way to represent images using code.
Okay, so instead of like a JPEG or a PNG, which are like pixels, it's code.
Exactly. It's code. And that means you can resize them without losing quality. You know, they stay sharp.
Oh, that makes sense. Like zooming in on a graph and it still looks crisp.
Yeah, exactly. And the cool thing about SVG is that it's already being used by a lot of educational platforms like Khan Academy and IXL for their math problems.
Oh, I see. So it's like this is a format that's already kind of integrated into how we teach and learn math online.
Right. And that makes it a really natural fit for this kind of research.
So the AI is essentially generating like a blueprint for the diagram in code.
That's a great way to put it. Yeah.
But why is this research so important? I mean, we've had math diagrams for, you know, centuries. What's the big deal about having an AI create them?
Well, you've got to think about the scale of things right now. If you want a good math diagram, you pretty much have to draw it yourself, or maybe use some specialized software.
Which can be, you know, time consuming or require specific skills.
Exactly. It's not something that can easily be done for like every single student and every single math problem. And the existing software out there often needs you to know some coding, which, you know, not every teacher or student has time for.
Right. So this could be huge for making math more accessible.
Absolutely. Imagine a tool that could just instantly generate a diagram for any math problem that would be incredible for teachers, for students.
Well, yeah, like no more struggling to draw those perfect circles or trying to figure out how to represent fractions visually.
Gone all automated.
It's exciting, but to really appreciate this paper's approach, I think we need a little bit of like historical context. Like, how did we get to this point where we're even thinking about using AI for this?
That's a good point.
I
mean, you're right back in the day, if you wanted a math diagram, you had to draw it yourself with a, you know, ruler and compass.
Yeah, like the good old-fashioned way.
Yeah, and then came specialized software, which was a step up, but it was often clunky and still required some coding knowledge.
So not exactly user-friendly for the average teacher or student?
Not really, and that's where LLMs come in. They've shown this remarkable ability to generate all sorts of things, text code, even images.
Right. They're like these multi-talented AI models.
Exactly. And so the researchers in this paper thought, why not try to leverage these LLMs to generate math diagrams?
It seems like a pretty natural progression given how powerful LLMs have become.
Right. It's like, okay, we can use them for language, we can use them for code, why not visuals too?
But how did they actually train the LLM to create these diagrams? Did they like feed it a bunch of math textbooks and say, go wild?
Not quite. They used a method called in-context learning. It's like they're giving the LLM a crash course in diagram creation.
Okay, so walk me through that. What does that look like?
Well, they feed it a few things. First, a description of the task they wanted to do, you know, generate a math diagram.
Right. Okay, look, a set of instructions.
Exactly. Then they give it some instructions on how to format the output, like using SVG code.
Okay, so it knows what language to speak in.
Right. Then they show it an example diagram from the same math topic they're working on.
Oh, so it's like they're giving it a model to follow.
That's it. And then finally, they give it the target problem that they want a diagram for.
So it's like they're saying, see, this is what we're going for now. You try.
Precisely. And the amazing thing is it actually worked. The LLM was able to spit out SVG code that, when rendered, created a pretty decent math diagram.
That's impressive. I mean, I'm picturing like lines and circles and all the elements you'd expect in a math diagram.
Yeah, it's pretty remarkable. But I imagine evaluating the quality of these diagrams isn't as simple as like just looking at them, right?
Yeah. How do you determine if a diagram is good beyond just like, does it look right?
That's a really key question. And you're right, comparing the SVG code itself doesn't tell you if the diagram actually conveys the information it's supposed to.
Like, does it actually represent the math accurately?
Exactly. So to address this, the researchers took an interesting approach. They used another LLM for a visual question answering task, or VQA.
Whoa, wait, hold on. Another LLM? So now we've got two LLMs in the mix.
Yep, it's like AI judging AI.
So how does this VQA thing work?
Okay, so they start with a human-made diagram, what they call the ground truth.
Okay, so the gold standard diagram?
Exactly. And then they use this second LLM to generate questions based on that ground truth diagram.
Oh, I see. So questions like, what is the area of this triangle, or how many sides does this polygon have?
Exactly. Questions that you would need the diagram to answer.
God, and then what?
Then they test how well both the ground truth diagram and the LLM generated diagram can answer those questions.
So it's like they're having this second LLM act as like a teacher or a judge.
Right. It's saying, okay, here's the question. Can your diagram answer it?
That's so clever. What did they find? Did the LLM generated diagrams pass the test?
Well, the results were actually quite promising. The pipeline works surprisingly well in a lot of cases. The LLM-generated diagrams were comparable to the human-made ones in terms of answering the VQA questions correctly.
That's really encouraging. It's like the AI was able to learn not just how to draw shapes, but also how to represent mathematical concepts visually.
Yeah, it's pretty amazing. But of course, there were some hiccups along the way. And those hiccups, I think, are actually some of the most interesting parts of this research.
Oh, I love a good AI fail. Tell me about the hiccups.
Okay, well, for a simple multiplication problem, like 7 times 2, the LLM absolutely nailed it. The diagram it generated was almost identical to the human-made one, perfectly capturing the concept of repeated addition.
Okay, that makes sense. It's a pretty straightforward concept to visualize.
Right. But then they tried a fraction comparison problem,
right.
12 versus 22.
Okay, a little more complex.
And the LLM struggled a bit. It couldn't quite represent the nuances of that concept with the same level of detail as the ground truth diagram.
Interesting. So it's like the LLM could handle the mechanics of drawing, but it struggled a bit with the deeper mathematical meaning behind the representation.
Exactly. And this highlights a crucial finding from this research. While LLMs show promise in this area, they still need those clear instructions and context to create those really effective diagrams. They're not yet at the level where they can understand the math independently and just generate a perfect diagram on their own.
So they still need some hand-holding?
A little bit of guidance, yeah, but that's okay. I mean, it's still early days for this kind of research.
So they need those clear hints and context. Did they try any other variations to their approach? Like, did they experiment with different ways of feeding information to the LLM?
They did, actually. And some of those experiments led to some pretty interesting and hilarious results.
Oh, I'm all ears. Tell me more.
Okay, so one thing they tried was using a text-to-image model instead of SVG.
Okay, so instead of generating code, they had it generate an image directly.
Right, and the results were, let's just say, not pretty.
Oh, I love a good AI fail. What happened?
Well, they gave the LLM a textual description of that same multiplication problem. Something like a diagram of 7 rows of 2 circles each.
Okay, straightforward enough.
They fed that to a text-to-image model, hoping to get a neat grid of circles. But instead, they got this bizarre jumble of shapes, barely resembling circles, with random numbers scattered everywhere.
Oh, no, it sounds like a math nightmare.
It was like something out of a fever dream. And it really highlights why using that structured code like SVG is so important. The LLM can actually understand and manipulate the code to create a more accurate representation.
Right. It's like the difference between trying to build a house with loose bricks versus having a detailed blueprint.
Exactly. The blueprint gives you that structure and precision that you need.
Okay. So SVG, good text to image, not so much. Did they try anything else?
They also tried having the LLM generate the textual hint first before creating the diagram.
Oh, so instead of giving it the hint, they had it come up with its own.
Right. And that actually led to a slight drop in performance, suggesting that having that clear pre-written hint is really crucial for the LLM to create a good diagram.
Interesting. It's like it needs that clear roadmap before it can start drawing.
That's a great way to put it. And they also tried another variation where they provided the previous hints diagram as context, like saying, okay, here's what you drew before. Now build on that.
So giving it a sense of continuity.
Exactly. Like, here's how the story's unfolding so far. Now draw the next scene.
And did that help?
It did, actually. The LLM is able to generate diagrams that align better with the ground truth when it had that extra visual context.
So it's like the LLM benefits from seeing the bigger picture, building on what it's already created.
Exactly. Context is everything.
I think this has been a great overview of this first part of the paper. We've talked about the motivation behind the research, the approach they took, and some of the key findings, both the successes and the failures.
Yeah, I think we've covered the main points here. The potential of LLMs to generate math diagrams, the importance of SVG, and the role of those clear instructions in context.
So are you ready to move on to novel notions?
Let's do it. I'm excited to hear what you've come up with.
All right, well then let's take a quick break and we'll be right back with some thoughts on where this research could lead.
Okay, so we're back and it's time for our favorite segment, novel notions.
Yes, this is where we get to kind of step outside the boundaries of the paper and think about the what ifs, like where could this research go next? What are the exciting possibilities?
Exactly. It's all about blue sky thinking.
Yeah.
No limits.
I love it. So where do we start? What are some novel notions that came to mind as you were reading this paper?
Well, one thought that really jumped out at me is that, we've been talking about using LLMs to generate these static diagrams, but what if we could make them interactive?
Interactive. That's a really cool idea. What do you mean by that?
Imagine a diagram where students could actually manipulate the elements and see how the math changes in real time.
Oh, wow. So it's like taking those static visuals and turning them into dynamic learning tools.
Exactly. Students could really experiment and explore the concepts in a much more hands-on way.
Yeah, I can see that instead of just looking at a diagram of a triangle, they could drag the vertices around and see how the angles and the area change.
That's it. Or imagine a diagram where you can drag a point on a graph and watch the corresponding equation update instantly.
Oh, that would be so cool. It's like you're really seeing the math come to life.
Right. And I think it can make learning much more engaging and intuitive, especially for students who are more visual learners.
I'm just picturing a virtual math playground where kids can build and manipulate geometric shapes and see how changing variables affects equations and basically just play with math in a way that's fun and exciting.
Yes, exactly. And this idea of interactive diagrams really ties into the bigger picture of personalized learning,
Personalized learning, so tailoring the learning experience to each individual student.
Precisely imagine an AI tutor that not only provides explanations, but also generates custom-made visual aids that are tailored to each student's needs and learning style.
Wow, that would be amazing. So if a student is struggling with fractions, the AI could create an interactive diagram that specifically helps them visualize and understand those concepts.
That's the idea. It's like having a personal math coach that can adapt to your individual learning journey.
And it could even adapt in real time, right? If the student is grasping a concept quickly, it could move them on to more challenging material.
Right. Or if it's struggling, it could offer additional support or break things down into smaller steps.
It's like having a tutor that can read your mind and know exactly what you need.
Well, maybe not mind reading, but definitely a tutor that's very attuned to the student's progress and understanding.
This all sounds incredible, but how realistic is this? I mean, are there any existing technologies that could actually make this kind of interactive, personalized learning experience possible?
I think there absolutely are. We're already seeing a lot of exciting work in areas like interactive data visualization and educational technology.
Right. There are those tools that let you play with data and graphs and create interactive simulations.
Exactly. And if we combine those advancements with the power of LLMs, I think we could really start to see this vision become a reality.
It sounds like we're on the cusp of a major shift in how we teach and learn math. It's moving away from those static textbooks and worksheets and towards this more dynamic and engaging experience.
I agree. It's a really exciting time to be working in this field.
So we've been talking about these grand visions for the future, but let's circle back to the paper for a moment. What are some of the key takeaways from this research that might actually inform the development of these interactive personalized learning tools?
Well, I think one crucial takeaway is the importance of using those structured representations like SVG.
Right, that code-based format.
Exactly, because as we saw when they tried using a text-to-image model, the results were pretty chaotic. The LLM really needs that structured code to be able to understand and manipulate the diagram in a meaningful way.
Yeah, it's like trying to build a house with loose bricks versus having a detailed blueprint.
Precisely. That blueprint is what gives you the structure and precision that you need.
Another key takeaway, I think, is the importance of context. Remember how providing the previous hints diagram actually improved the LLM's performance?
Yes, that's a really important point. It suggests that for these interactive learning experiences, we need to think carefully about how to present information in a way that builds on previous knowledge and concepts.
Like creating a visual narrative.
Yeah.
guiding the student through a series of interconnected steps.
That's a great analogy.
Yeah.
And I think it's crucial for creating a learning experience that's both engaging and effective.
And one final thought I'd add is that, remember how the LLM struggled with that fraction comparison problem?
Yes, where you couldn't quite capture those nuances.
Yes. I think that highlights the need to really think carefully about the pedagogical aspects of diagram design. Even with all the bells and whistles of interactivity, the visual representation itself still needs to be carefully crafted to effectively convey the underlying math concept.
You're absolutely right. It's not just about making things flashy and interactive.
Mm-hmm.
The content and the way it's presented still need to be pedagogically sound.
So it's about striking that balance between engagement and effective instruction.
Exactly. We want to create tools that are both fun to use and help students learn.
Well said. I think we've covered a lot of ground in this novel notions section. We've explored the possibility of interactive, personalized learning. We've talked about the technologies that could make it happen. And we've highlighted some key takeaways from the paper that might inform the development of these tools.
Yeah, I think we've had a really fruitful discussion.
So before we wrap up this deep dive, is there anything else from the paper that you wanted to touch on?
Actually, there is one more thing I think is worth highlighting, and it's something that the authors themselves acknowledge in the paper. Yeah. It's about the limitations of this research. As exciting as the results are, it's important to remember that this is still very early stage work, and there's a long way to go before this technology is actually ready to be used in classrooms.
That's a good point. It's easy to get caught up in the hype and overlook the challenges that still need to be addressed. So what are some of the biggest hurdles that they still need to overcome?
Well, one of the key challenges is scalability. The researchers in this paper, they tested their approach on a relatively small set of math problems.
Okay, so they proved that it works in principle.
Right. But to be truly useful for teachers and students, this approach needs to be able to handle a much wider range of math topics and concepts.
Right, so it's going to be able to do everything from basic arithmetic to, advanced calculus.
Exactly. It needs to be able to scale up, and not just in terms of the types of problems it can handle, but also in terms of the different grade levels and learning styles.
Right. A diagram for a first grader learning about addition is going to look very different from a diagram for a high schooler studying trigonometry.
Exactly. It's not a one-size-fits-all solution.
Okay, so scalability, that's one big hurdle. Are there any others?
Yeah. Another challenge is making sure that the diagrams are pedagogically sound. We touched on this earlier with that fraction comparison example.
Right, where the LLM struggled to really capture the nuance of the concept.
Exactly. It's one thing to generate a diagram that looks nice, has all the right shapes and colors, but it's another thing entirely to create a diagram that actually helps students understand the math.
So it needs to be more than just aesthetically pleasing. It needs to be effective as a teaching tool.
Precisely. And that requires really careful consideration of how people learn best, how they visualize concepts. Yeah.
Right. We need to make sure that these diagrams are aligned with the way that students actually think about and process information.
And then there's the issue of accessibility.
Accessibility, so making sure that these tools are available to all students.
Right, exactly, regardless of their background or their learning differences.
Yeah.
We don't want to create a system that exacerbates existing educational inequalities.
That's a really important point. Technology should be a tool for equity, not a barrier.
I couldn't agree more. So while this research is incredibly exciting, it's important to acknowledge these limitations and approach the development of this technology thoughtfully and responsibly,
Absolutely. I think that's a great note to end on. We've explored the incredible potential of LLMs to generate math diagrams. We've brainstormed some really cool ideas for future applications. And we've also had a frank discussion about some of the limitations and the challenges that still lie ahead.
Yeah, it's been a really fascinating deep dive.
And it really has. So thank you so much for joining me today and sharing your expertise.
It's been my pleasure.
And to all our listeners out there, thank you for tuning in to TalkTensors. As always, the link to the paper we discussed is in the show notes if you want to delve deeper. And if you've been inspired by our Novel Notions segment, we'd love to hear your thoughts, share your ideas in the comments below.
Yeah, let's keep this conversation going.
Until next time, keep those neurons firing and stay curious.